Okay, so we're going to continue to talk about slope, and in particular, how to use slope to help us graph linear equations. And we'll use something called slope-intercept form, which I think you will remember. This is not going to be the first time you've seen it. So by the end of today, they're not going to be able to do all this stuff, but we should be able to graph linear equations and know what a linear equation is, and show that they have constant rates of change. Rates of change, another fancy phrase for slope, right? We need to be able to figure out the slope and the y-intercept of a line given its graph, its equation, and eventually 2 points on the line, but not today. And then determine the equation of a line given enough information. Okay? All right, some vocabulary first. And the first one, first thing you have there in your notes is a parent function. A parent function is the simplest function in a family of functions. Now, what that means is a family of functions, and so this is a function called an absolute value function. This is a function, again, an absolute value function, because they have absolute value bars in them. And they belong to the same family of functions. They have very common characteristics. They both have absolute value bars in them. What you'll learn later is that when you graph absolute value functions, they'll look like a V. They both will. Okay? But the parent function for this family would look like this. This is the very basic, the most simplistic absolute value function there is. And so this is your parent function. Okay? That's what I mean by a parent function. It's just the most basic form of a function. Okay? The parent function for what we call a linear function is y equals x, or f of x equals x. Remember that this notation is just your function notation. It means f of x. It's showing you if you have an input of this value x, then the function will do some stuff with it. Okay? That's just your function notation. But anyway, the linear function, the parent of that linear function is y equals x, or f of x equals x. That's the most basic form of a linear function. Okay? Some more. What is a linear function or a linear equation? A linear equation is one that models a linear function. When you graph it, what base word is in linear? It's line. So when you graph a linear equation or a linear function, you should graph a line. That's what we're going to be doing here today. Okay? Part of what we need to understand about graphing is that very often graphs will have what's called a y-intercept. If it's a function, it will definitely have a y-intercept. And the y-intercept is the y-coordinate of a point where the graph crosses the y-axis. So it's where it hits the y-axis, simply put. And remember, the y-axis is the vertical axis, and the x-axis is the horizontal axis in the coordinate plane in a graph. Okay? So that brings us to, how are we going to graph a linear function or a linear equation? Well, there's a couple of different forms of a linear equation, and the most common one is the slope-intercept form. Do you remember what slope-intercept form was? Okay, hopefully you're thinking it's y equals mx plus b, because it is. That's your slope-intercept form. Why do we call it slope-intercept form? That's because this guy is your slope, and this guy is your intercept. And more specifically, m is your slope. The coefficient on x is always your slope. And the constant at the end there is always your y-intercept. It'll tell you where your line hits the y-axis. Okay? So, let's go pick out some slopes in y-intercept. Y equals 5x plus 2. It's in slope-intercept form, and math people aren't very creative. If it's slope-intercept form, then you should be able to find the slope in the y-intercept. And we do. The slope is always the coefficient on x, so your slope is here, and your y-intercept is always the constant, and so it's 2. Okay, make enough sense? What's the slope and the y-intercept for that guy? If you're looking at this, then hopefully you understand that the slope is 1/4, because that's your coefficient on x, and your y-intercept, there's nothing out here. So it's like you're adding, or your constant is just 0, which is different than if you don't see a number as a coefficient, right? So what's the same thing as adding nothing? It's adding 0. So your y-intercept is going to be 0. Okay? Different if you don't see a number in front as a coefficient, right? What's the same thing as multiplying? What do you multiply by to get the same thing? Because coefficients are always multiplied by, right? If you don't see a number there, what's really there? It's really a 1. So it's a little bit different. So your slope here would be 1, and your y-intercept would be a 2. Okay, so it's a little bit different when you don't see a number as a y-intercept, or you don't see a number as a slope. Okay? All right, slope and y-intercept for this guy. Your slope is, right, 1/2, and your y-intercept, because this is minus, is -5. Okay? Bring your minus as a negative. And almost always in math do we do that. All right? Now, what if we want to go the other way? What if we have the slope and the y-intercept, and we want to come up with the equation? Well, since we have the slope and the y-intercept, then we're going to want to put it in slope-intercept form. In other words, that y equals mx plus b. And just plug in your m here. Your slope is always the coefficient on x. And you plug in your b here. Your y-intercept is always the constant. Since it's negative, we make it a -1. Okay? Piece of cake, right? Try this guy. What would the slope-intercept form of the line look like with this slope and this y-intercept? Remember, y equals mx plus b. So where do you put your m? Here, right? As your coefficient on x. And where do you put your b? Here, right? As the constant. So y equals -4x plus 7. Try this guy on your own. Stop the video if you need more time. Write out the equation, then come start the video and check your answer. Okay? Y equals mx plus b. Plug this in for your slope, this in for your y-intercept, and y equals -2x plus 8/5 is your equation. Okay? Easy, 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 right? Hopefully. All right. Now let's get into the graphing portion of this a little bit. So write an equation from this graph. Okay, remember the equation is going to be in slope-intercept form. So what do we need to write the equation? Well, again, math not being real creative in how we name stuff, we need the slope and we need the y-intercept. Okay? Should not be a problem. The y-intercept, again by definition, is where the graph hits the y-axis. Remember that this is the y-axis, this is the x-axis. And so the graph, the line, hits the y-axis right there at 1. So your y-intercept is 1. Now, your slope you have to get from walking from one street corner to the next. So here's the street corner, and right here is a street corner, and right here is a street corner. So how far do you have to rise, and then how far do you have to run? Remember, slope is rise over run. Well, you have to rise, 1, 2. So that's going to be up 2, so that's positive. And then you have to run, 1, 2, 3. And so your run is +3 since you're going to the right. Now you have your slope and your y-intercept. You can go write your equation. y equals, slope is always the coefficient on x, and the y-intercept is always the constant out here. And so there's the equation for this graph. Okay? Think you got it? Try the next one. Try this guy. Or wait, we'll come back to this guy. Try 9 first. Okay? Stop the video if you need to, and then start it again to check your answer. Okay, what'd you come up with? Again, slope-intercept form of the line, we need the slope and the y-intercept. Y-intercept's the easier one to find. It's where it touches the y-axis. This guy's at 3. And then we need another straight corner to walk to, which is here. So we have to go down 2, down is negative, and right 1, right is positive. So now you have your slope. So y equals negative 2. And if you want to drop the 1 when you write your equation, fine. I know I keep saying I like slope as a fraction, and I still do, but very often you don't see that denominator of 1, if that's what it is, when people write the equation of a line. So you can drop it when you put it into the equation. Okay? One way to check, your line here goes down to the right, and so your slope should be negative, so make sure that your slope is negative. Okay? You at least have half of it checked. All right? Now, let's go back to 8. I'll give you a second to think about it. Okay? But try it and then start the video again and see if you're right. Okay? We still need slope and we still need y-intercept to write the equation, right? All right, well, the y-intercept, where does this thing touch the y-axis? It touches right there, which is at negative 3. Slope, we need rise over run. Well, the next street corner to walk to is, let's say there, or there, or there, or there. Right? How far do you have to rise to get to your street corners? Well, nothing, right? You don't have to rise at all, so it's 0. You have to run 1, but 0 divided by 1 is just 0. So your slope is 0, so your coefficient on x is 0, and your y-intercept is minus 3. Well, 0 times x is just 0, so you get 0 minus 3, which is just negative 3. So the equation of this line is actually just y equals negative 3, which makes sense if you remember your Vux and Hoy. This is a horizontal line, so we're going to use Hoy. Horizontal line where your slope is 0, and your equation should look like y equals some number, because y is always the same value. In a horizontal line, all of these points have the same y value. They're all negative 3. So we just use the y value to write the equation. So y equals negative 3. Okay, so a little tricky because it's a horizontal line, but not too tough. So if it's a vertical line, then your equation is just going to be x equals whatever all those x values are. Every point on a vertical line will have the same x number as its coordinate, and so the equation becomes x equals whatever that number is. Okay, we'll talk about that more when we see one. All right, now we want to go the other way, right? So we have a graph, we could write the equation. Now we want to go from the equation to a graph. If you have the linear equation in slope-intercept form, remember that slope tells you how to walk from one street corner to the next, right? Or from one point to the next. So we have to have a point in order to get started. And so the first thing we have to do is create our point, and the easiest way to do that is to go to the y-intercept, because slope-intercept form will tell us what that is. From the y-intercept, we're going to use the slope to walk to 2 more points. Okay? And then we connect our dots and make our line. So, example. Here. From your equation, Your slope is 1/2, and your y-intercept is -1. You should be able to find those by now. Now, slope is 1/2. That tells you how to walk from one point to the next. But we don't have a point to start from. So we've got to plot that point first. So you go to your y-intercept first. This graph is going to hit the y-axis at -1, and so we put a point on -1. The slope is 1/2. That's how far you're supposed to rise and then run to get to your next point. So we rise 1 and run 2. So we go here. We rise 1 and run 2, and there are 2 other points. Okay? Now, we get a positive slope if we go up and to the right, because both of those movements are positive. We can also get a positive slope if we go in two negative directions, right? If we go down 1 is -1, left 2 is -2, 2 negatives still make a positive, and so it's still going to be a positive slope. So I should be able to go down 1 and left 2 and get another point on that line. So you can create as many points as you want. If you want to create your 2 points from your y-intercept, you can go both directions. And then just draw yourself a nice straight line through those points, and hopefully it's a little bit better than that one, but you get the picture, hopefully. Okay? All right. Hopefully not too tough. Try this guy. Go graph -3x plus 4. You stop the video, and then start it again to check your answer. Okay, your slope, in this slope-intercept form, your slope is -3, and as a fraction, -3/1. I think it's helpful to see the run in your slope. And then y-intercept is just 4. So we need to go to 4 on the y-axis. And if we try to use the slope, -3/1. -3 means we go down 3 first and right 1, because 1's positive, so down 3 and right 1. And so there's your graph. Again, a little bit better to draw it through those points. Okay? Your slope is negative in your equation, so your line should be going down to the right. Okay, you got another one for you to try. Stop the video, give it a shot, and start it again to check your answer. Okay? So, slope-intercept form. Your slope, there's not a number in front of the x, just a negative sign. But remember that if there's no number in front, then there's really a 1 there. So your slope is -1/1. Your y-intercept is simply 3. And so now we're ready to go graph. Start by the y-intercept. Got to have a point to go from. So put your point there on the y-axis at 3. And then your slope tells you to go down 1, right 1, down 1, right 1, and then you can graph. Now, again, the negative can go anywhere. If your slope is negative, your negative can be in the numerator, or your negative can be in the denominator. So we could move this negative down here if we really wanted to, and that would give you your other direction. So you could go from the y-intercept, you could go up 1 and left 1, and you're still going to fall on that line. Okay? So in either direction. So it should look like that. Okay? Here's 13. Give that a shot, then start the video and check your answer. Okay, slope is here. It's 4. 4/1. Y-intercept is here. Bring the minus sign as a negative. And now we're ready to go. Start at -5. Now your slope is 4/1. So go up 1, 2, 3, 4/1. Up 1, 2, 3, 4/1. And there's your line. And you can keep making these points because the slope for this line, gotta make a better line than that, is going to be the same all the way up this line. Because that slope is constant. The rate of change is always constant. Okay? But there you go. Okay? Got one more for you, number 13. Wait, we just did 13. That's it. Yeah, that's it. Okay? Hopefully you got it. Homework's out in Canvas. Go pick it up. Make sure you have that done by next time, and we'll see you then.